Good evening, students. Let us see about the first what is meant by a controller, what are the different modes of controller, and let us explore about the discontinuous modes of controller modes in this today's session, right? So first, what is a controller? Okay, so when you take a controller, you need to define what is a controller. Okay, so please don't use the word controller is used to control the process. That is not a correct definition. Say for example, if you want to ride a bicycle, you need to see what is the road condition. Accordingly you are going to increase the acceleration or decrease the acceleration. Okay, so you will see. Okay, so with the help of eyes is a sensor. With the help of the eye you will see what is the road condition, and based on that your brain is going to give a signal to your hand. Accordingly you are going to give acceleration, increase acceleration or decrease the acceleration. Okay, so based on this example, let us define what is a controller. Okay, so controller is a device, okay, which may be either a mechanical, pneumatic, hydraulic or electronic, which monitors and physically alter the operating conditions of dynamic system. Okay, so you may think over, so it is going to monitor. Okay, so please don't use the word controller is going to control the process. A controller is going to monitor and physically alter the operating conditions of dynamic system. The best example is a speed control of an automobile system. Okay, so you can see this is a basic block diagram of controller. You can see very well the controller, the input to the controller is a set point minus a process variable, and the output of the controller is a control signal. Right. So when you categorize the controller, we are categorize the controller into three modes, that is a discontinuous mode, continuous mode, and composite mode. So under discontinuous mode, you have on off multi-position floating control, and continuous mode you have a proportional control, integral control, and derivative control. And coming to the composite control, we have a two mode and three modes. So under two mode you have a PIPD, and the three mode you have PID. Okay, so two mode, PI stands for proportional plus integral, PD stands for proportional plus derivative control mode. Okay, so today's session we are going to explore about the discontinuous control mode. Okay, so before moving to the controller modes, you should know what are the action the controller is going to take. One is a direct action, another one is a reverse action. Okay, if the control output increases with the increase in the controlled variable, you call that as a direct action. If it decreases with the increase in the control variable, then it is called as a reverse action. In some cases, there will be an inverse response process will be there. In that case, you need to decrease with the increase in the control variable. That is called the reverse action. Okay, and also it is very clear that the control signal is always a function of the error signal. Okay, so coming to the discontinuous mode, first one is a on-off controller, or it is also called as a two-position control, or it is also called as a bang control, where the control signal is either P max or P minimum if error is greater than 0 or if error is less than 0. Okay, so P of t is equal to P max if E greater than 0, or P of t is equal to P minimum if E less than 0. Okay, so it is going to remain in only two position, either a minimum position or maximum position. The controller output has only two possible values. Okay, so that is a drawback of this on off control, because it can going to remain only either in the on position or off position. The valve remains in on or off position. Okay, so in practical cases you will have a deadband, and you will have a, that is ideal relay. This is a biased relay where you have some deadband, and it is going to remain on after that particular tolerance band, and it is going to remain off beyond the tolerance band. Okay, and next case is a on-off controller. The drawback of on-off controller, it can opt only in the two position. To overcome that, we are going for an intermediate position, that is called as a multi-mode or multi-position control. In that case, you are going to choose a two error signal. One is E1, another one is E2, and you are going to see whether it is whether the control signal is greater than E2, it is fully open, or if it is between E1 to E2, it is 50 percentage open, and if it is less than even, it is 0. Okay, so that is the discontinuous control. It is used in the attempt to reduce the cycling behavior and overshoot and undershoot in a on-off controller. So if you take on-off controller, so it is going to always keep on and off. At that case, you will have a cyclic behavior. To overcome that, you go for a multi-position control, where you are going to have an intermediate position. And okay, so you can see that P of t is equal to 100 percentage, or if it is 50 percentage, or it is 0 percentage. Okay, accordingly you are going to use the discontinuous control mode. And the final one is a floating point control. Okay, so floating point control, in the it's nothing but the specific output of the controller is not uniquely determined by the error. If the error is 0, the output does not change, it remains float at whatever setting it was. And when the error went to 0, when the error deviates from the 0, the output the controller will begin to control output begin to change. That is called floating control. Okay, so these are the different type of discontinuous modes of control. You have a single speed floating control or multi-speed floating control. Okay, so in the single speed, the output of the control element changes at the fixed rate, whereas in the multi-speed, there will be a several possible speed rate are changed by the controller output. Okay, so that is called the multi-speed control modes. Okay, so with this, we'll move to the next type of controller modes called continuous control mode in the next session. Thank you, students.